Yeah, welcome back to my session matrices. In the previous lecture, we have done multiplication of matrices and we have seen the properties of multiplication. It was the only theory part. Today I am taking some good questions which are based on multiplication of matrices. So take first problem number 1. Here two matrices A and B are given and we have to find AB. So for AB, you write the values of A and B and use the same rule. What is the rule? Take first row of first matrix and first column of second matrix, multiply their corresponding element and add it. So 0 into minus 1 plus 2 into 0. This is one element. Again, apply the same process for second column with the first row 0 into 3 plus 2 into 0. This is second element. Similarly 0 into minus 1 plus 0 into 1 and finally 0 into 3 and 1 into 0, and we are getting a matrix which is a null matrix or zero matrix. So what is important here, I have mentioned here, it means when the product of two numbers say A and B is 0, so by product law we can say either A is 0 or B is 0. But here you can see both matrices A and B are non-zero, but their product is 0. So you must be careful. Now come to the second problem, which is very interesting and very tricky because here only single row is shown. One matrix A and matrix B is given. We have to find AB. So you are already knowing it's a row matrix and second one is a column matrix. If you see, first matrix order is 1 cross 3 or 1 by 3. Why I am saying? Because this matrix is having only one row and three columns, and second matrix have three rows and one column. So these two numbers are same, therefore product is possible and the final matrix will be of order 1 by 1. It means we will get a single element. So what is the rule? Rule says take the first row and first column 1 into 2 plus minus 1 into 4 plus minus 2 into 0. You just solve it, you will get minus 2. Come to the next problem, which is based on previous problem data. We have to find BA also. So then put the value of matrix B and A. Since it's a column matrix, it's a row matrix. So what we will observe here, matrix B order is 3 cross 1 and matrix A is order of 1 cross 3. So since both numbers are same, so we will get a matrix whose order will be 3 by 3. So apply the rule. Row of first matrix, column of second matrix, 2 into 1. Then next row of first matrix, column of second matrix here. Row of first matrix, column of second matrix here. Again row of first matrix, column of second, row of first, column of second, row of first, column of second. Similarly for this also. So what we are getting? This matrix. And obviously this matrix is of order 3 by 3. Correct? Now take fourth one, problem number fourth. And problem number fourth is also a very important property of diagonal matrix, because matrix P is a diagonal matrix and Q is also a diagonal matrix. Here principal diagonal elements are x, y, z, and here it is a, b, c. What we have to prove? We have to prove that the product PQ is defined as well as QP is defined. It means both product are defined and both values are same. How? If you observe this, actually the product of two matrices, what it is showing, corresponding elements are multiplied only, you can see. Okay, so this property you must remember, and this property will help you in objective type problems where you can save your time also. So how to prove it? Proving is so simple. To find PQ, you write the value of P and write the value of Q, and use the same operation: row of first matrix, column of second matrix, multiply corresponding elements and add it. So x into a, 0 into 0, 0 into 0. So finally you will get only xa. For the second column, x into 0 plus 0 into b plus 0 into 0. Similarly, first row and third column, x into 0 plus 0 into 0 plus 0 into c. So finally we will get xa 0 0 0 yb 0 0 0 zc. Similarly, we can multiply q into p. So what it shows when diagonal matrix are of same order is given, then both product AB and BA are possible and the product is commutative. In my previous lecture, I have given one note, so please add one more things, that when the two matrices are a square matrix, its product is commutative, but this is commutative only when the matrices are of the same order. Correct? Now come to the fifth problem. It is different type of problem. You can see a matrix A is a square matrix, and such that A square is an identity matrix. So we have to find the simplified value of A minus identity matrix cube plus A plus identity matrix cube minus 7 into A. So it is so simple, like expansion of polynomial, like you have seen, like a minus b ka cube. So you apply the same formula: a cube minus b cube minus 3ab in bracket a minus b. Similarly, a plus b whole cube, a cube plus b cube plus 3ab in bracket a plus b. Minus 7 is same: a cube minus b cube minus 3a square b plus 3ab square, a cube plus b cube plus 3a square b plus 3ab square minus 7a. So here few things are cancelled. You can see minus 3a square I plus 3a square I cancel, and finally I cube and minus I cube cancel, a cube 2a cube, 3ai square 3ai square 6ai square, finally minus 7a. Now this step is important because what is given? It is given that a square is I. What is given? Given a square is equal to I. So a cube can be written as a square into a, because we can write, in case of matrices we can do this. This power can be split into a square into a. 6 I square is 1. You must remember it's a property of identity matrix. Either you square, make it cube, make it power 4. I square is I, and a into I is a. We have already discussed. Now this a square can be write as I because it is given, and a is same. This 6a minus 7a same. Now come to here, I into a is a, and finally we are getting a. So here two important things you are getting. One is that the value of I square is always I, and A into I is always A. Okay. Now take problem number 6, where one condition is given: A minus 2I, A minus 3I is equal to O. It is not 0 actually, it is a null matrix. Remember one thing, if this left hand side portion is matrix, so right hand will also be a matrix. It should never be 0. Where A is a matrix 4, 2, minus 1, x. So we have to find the value of x. This problem is so simple. You do one thing, take left hand side, put the value of A minus 2. In place of I, we already know it's a identity matrix of order 2 by 2. Same thing here, value of A minus 3 value of I is equal to null matrix. This is same, multiply 2 inside, so you already know this 2 will be multiplied with each element, so it is 2 0 0 2. Same thing here, you can see this matrix is same, it is 3 0 0 3. Now directly subtract, because 4 minus 2 is 2, 2 minus 0 is 2, minus 1 minus 0 is minus 1, and x minus 2. So this is actually this result, and subtract these two matrices, you will get this matrix, and it must be null matrix, so write down 0. Now final solution, you already know how to multiply two matrices, row and column, row and column. Similarly, row and column, row and column. So we are getting this, and this is equal to a null matrix. After comparing the elements, because both matrices are same, so 2x minus 2 must be 0, minus x plus 1 must be 0, and x square minus 5x plus 4 must be 0. So from here we are getting x is equal to 1, from here x is equal to 1, and after simplification we will get x is equal to 1 and 4. So actually by taking three different conditions, we are getting 1, 2 and 2, total 4 values of x. So but we have to do one thing, we have to take common value from all the values, 1 1 1. So final answer is 1. Don't write in examination that final answer is 1 and 4. It will be wrong, because 4 will not satisfy the previous equation. So be careful here. Now take last problem based on matrix multiplication. One matrix A is given, and we have to find x and y such that one matrix equation is given: a square plus x into I2 is equal to y into a. So it is simple, you write the value of a square, because a square means a into a. So a square is a into a plus x. I2 means identity matrix of order 2, so I have written here, is equal to y, and the value of a I have kept here. Now after multiplication you will get 16, 8, 56, 32, plus x will be multiplied here is equal to 7, y will be multiplied here. You just add it, you will get this matrix as well as this matrix. Compare it, so obviously corresponding elements will be equal. So 16 plus x is equal to 3y, 8 is equal to y, 56 is equal to 7y, and 32 plus x is equal to 5y. So when you will do y is equal to 8, from here y is equal to 8, put the value of y is equal to 8 here, you will get x is equal to 8, and finally when you put the y is equal to 8 here, again you will get x is equal to 8. So we are observing a common solution everywhere. So the final values, that x is equal to 8 and y is equal to 8. I hope everything is clear, and it's a request you do more problem based on matrix multiplication, and whatever doubts you are having, you just discuss to me. Thank you.